So here we have a permanent magnet DC motor. As you can see, we have the 9-volt battery connected with the current starting on the positive terminal, going through the red wire, and out to the black wire to the negative terminal. We have a permanent magnet in the middle with the north pole facing upwards. So essentially, for this concept to work, we do have a commutator here, and that was created by shaving off half of the insulation on one side of the wire and shaving off the full insulation on the other side of the wire. So essentially, this acts as a rotary electrical switch, you can call it that, from the current being cut off at certain points of rotation. The current is allowing the winding to spin and then cuts off, and the insulation becomes in contact with this conductive safety pin. So here we have a permanent magnet circuit diagram. We have the 9-volt battery going through, and it's expected for it to turn this way towards me, and that is what is happening here. And that is happening because we are using Bill's law, which is F equals BIL in the North and South Pole convention. So the magnetic flux is coming out of the page, going up and then back to the South Pole, which is directly beneath the magnet. And with this circuit diagram, or this schematic here, we can see that the magnetic flux density is going up, the current is going right, and the force is coming out of the page, and that's occurring at the top. And at the bottom, the current is coming to the left. The magnetic flux density is still staying the same, it's going out or going up, and the force is coming or going into the page. So commutator orientations, the current goes through the stripped insulation, which allows it to flow. So current is flowing through at that point, but that there's interrupted current when the insulation part is touching this conductive pin or safety pin. So it's cutting off the current flow, but it's happening so fast, it's still allowing it to spin. And this is as expected. Due to Bill's law, the motor is spinning towards me, and if I would to reverse the polarity of this, it would be turning the opposite direction.